So lots of great conversations going on in the room, which is fantastic. And the only thing that can ever change anything is when people change their minds or think differently. Because nothing will ever change until people change it, right? So your interaction with each other and you're working with each other, you're networking, you're exchanging of information and ideas and bonding, like basically, like this human community here is, in some ways, I guess it's like the community of microbes in the soil. Don't take that the wrong way. That's like soil can't function without that microbial community, right? And our society is not going to function without our human community, and it's something that we've really lost track of, I think, in many ways. So I can give you information, but you really need to network with each other, and you'll come up with all kinds of amazing ideas. I have no doubt about that. The thing that really excites me about RegenAg is some of the new innovations that we're seeing, because people are just starting to think outside the square and come up with amazing solutions. Once we actually know what it is that we're working on, what the processes are, then it's and just open up your mind. I like that saying about, you know, the mind is like a parachute. It works best when it's open. So I'm just going to say a little bit. I'm not going to say a lot in this section about economic security, because for me it's kind of, well, it just makes absolute sense. I mean, is economic security going to be linked to dysfunctional, deteriorating soil, or is it going to be linked to regenerating, abundant, vibrant, healthy soil? I mean, it's kind of a... but there is one piece of work that I do want to mention. Some of you have probably seen this before. It's from Darrin Qualman in Saskatchewan in Canada. He published a book last year based on this information, and the only thing is that his outlook on the whole thing has been a little bit depressing. He hasn't really talked that much about how we can change things. It's more or less like, well, you know, we're on the downhill run and it's not looking really good. And when you look at his figures, they certainly show that things aren't all that great. So I'm just going to show you his data. It's Canadian, but I guess they're not that far away, right? It also applies to the United States. It applies to Australia and New Zealand, South Africa, and many places in South America and Europe. So the fact that it's Canadian doesn't detract from its relevance. So Darrin put together this figure of Canadian net farm income over the 80-year period from 1926 to 2016. So what you see there, that blue line, is gross revenue from agriculture. And over time that's been increasing, but it also goes up and down. It goes up and down with commodity prices and seasons, and we all know that we have good years and bad years, both seasonal and market-wise. So that's hardly surprising, and it's good to see that that blue line is actually, the trend of that blue line is up. So that gross agricultural production is increasing and gross farm revenue is increasing. What is worrying is the green line. The green line is net farm income. So that's what farmers are taking home. So up till about like 1950s there, you can see that the green line and the blue line and the green line are following exactly the same trends. So if we have a great year seasonally, or if commodity prices are good, our gross revenue from agricultural production goes up and net farm income goes up, which is what we would like to see. But then in about the 50s, there's this kind of departure where the green line starts going down and the blue line keeps going up. And so, and there in 2006, you can see that the net farm income actually becomes negative. Is that red area there, and that's when the cost of producing corn was greater than the value of the corn. People still went out and planted corn, and people still are growing corn here in the United States now, and not making any money from it. And when you talk to corn farmers about why are you still growing corn, almost universally they'll say it's because all of our equipment is for growing corn, and that's something that we know what to do. We don't have equipment for growing anything else. We don't know how to grow anything else. So we are going to go out and possibly lose $200,000 or something by growing corn, because that's all we know how to do. So when I was saying is that the only way that we can change agriculture is by changing to 6 inches between people's ears. We really have to change how we think about things and our approach to things, and it's only people that can change things. So until corn growers in the United States change their attitude to only being able to grow corn, then we're going to have a lot of these issues that come about with monocultures and also with people losing money. So what Darrin Qualman worked out, and I will send a link to Isabel. You can actually read the article. It's a very short article. He describes it really well. But that blue area there, that's what the input providers get. That gross value of agricultural production, they're the people that sold the seeds, the fertilisers, the fungicides, the insecticides, the tractors, the fuel, and the accountants that kept track of it all. So it's all the service industries that revolve around agriculture, and they're all doing very nicely. Thank you very much. What he calculated was that in the last 32-year period of that graph there, so just in that last little bit, look at all that blue area there. Input suppliers receive 1.32 trillion of the 1.35 trillion of agricultural production. They took 98%. So 98% of all the hard work that farmers put into growing things was taken by the input providers. So are they going to tell you to use less fertiliser? Are they going to tell you to use less fungicide or less insecticide? No. They're going to say your crops won't grow without this, or your pastures won't grow without this. They're doing very nicely, thank you very much. Or you need this new kind of machinery, or you need this, or you need that. So there's been this big fear factor of, like, you're not even, what really, that plants won't grow without fertiliser? Whoever said that? It's like, well, an input provider that was selling fertiliser said that. So I think that the data is very relevant, and it does apply here to the United States. So the majority of Canadian farmers, they're supported by off-farm income, taxpayer-funded support schemes, and asset sales, borrowed money is exactly the same in the States, right? Debt in Canada, farm debt's at a record high. It's also at a record high in the United States and in Australia and New Zealand. So worldwide, just to summarise basically, I suppose, what I've said this morning, is that this approach to food production, this high input approach, has caused soil degradation because of the loss of soil biodiversity. Environmental pollution is everywhere. Don't think it's just restricted to the United States. I mean, one thing I will say about environmental pollution here is that 49 states have groundwater that has nitrate levels that is carcinogenic. You really, if any of you are drinking well water, groundwater, please, probably this state is probably, you might even be the 50th one that's not. It's more the high input states, but in nitrate levels in groundwater are off the scale. The EPA has regulated the threshold level for nitrate in groundwater at 10 parts per million. Why did they choose 10 parts per million? Because at 10 parts per million it kills babies. At 2 parts per million it's highly carcinogenic to adults. And it's very strongly linked, the nitrate levels in the water are very strongly linked to the incidence of cancer, and now they're showing it's strongly linked to some kinds of cancer, like colorectal cancer and those kinds of cancer, very, very strongly linked to nitrate levels. There's just been a huge fuss about this in New Zealand recently because people have recognised the rivers were polluted, highly polluted with nitrogen, but now that it's linked to cancer, it's become okay. So we actually are killing people with these high nitrate levels. Your soil test should actually show 0 nitrate, a leaf test should show 0 nitrate, and our food should have 0 nitrate. We don't want to have nitrate anywhere in our food production systems, and we don't need to have. So if we're running on a biological system, good levels of microbial diversity in our soils, we've had, for example, Ian and Diane Haggerty, I think, are featured in that book that you have, the booklet, around about page 30 something, 32, 33 or something. They were just speaking at No Till on the Plains about 2 weeks ago. Yeah, there we go. What page number is that one? There, you've got it too. 32, 33. So one of the things that you'll see on that page is a photograph of some plant roots that have fantastic rhizosheaths on them. I mentioned rhizosheaths this morning. Remember, it's that area of soil around the plant root where the soil particles are all stuck together in a column of soil. So what's happening inside that rhizosheath is that the plant is feeding free-living nitrogen, fixing bacteria that are able to fix all the nitrogen that their wheat crop needs. They grow about 40,000 acres of wheat. They don't use any nitrogen fertiliser at all, and they're farming in sand, basically sand. They have the highest protein content of any wheat produced in Western Australia. So how do they do that without adding nitrogen? They put a biostimulant on the seed, and the biostimulant that they use is rich in autoinducers, which are the chemical signalling molecules that microbes use to communicate with each other. So we're tricking the seed into thinking it's in a microbially active soil. The seed will then produce lots of exudates to support the microbes that it thinks are there or senses are there, because it's picking up on their signals. Microbes actually aren't there. But then when the seed produces all those exudates, the resident microbes in the soil respond, and then they form a relationship with that seed. So we're basically kick-starting it, and that's what a biostimulant does. You're not applying nitrogen, you're not applying phosphorus, you're not applying microbes, you are stimulating the seed into sensing that it's in a microbially rich environment, and it will respond by feeding those microbes. So that gets the whole thing sort of like underway and working. So, and the Haggertys, I think they call it natural intelligence farming. So they're basically, what they're doing is working with microbes in that system, and that's what we all kind of need to figure out. So we definitely don't need high analysis fertilisers. We definitely don't need the insecticides and the fungicides that come with, it's part and parcel. Once you start putting in on things, then everything falls apart. You need those other things. So nearly all those inputs there you really don't need. You might need the tractor maybe to plant stuff, and you need the seed. So spend the money on seed. So our approach to food production, and again, we've just like really narrowed the genetic base by growing one thing. You know, whether it be wheat or corn or soy, or just having, you know, a vineyard that's just got grapevines in it and bare ground between the grapevines, or a citrus orchard that's just got, you know, orange trees or lemon trees or something and bare ground between the trees, or cotton, you know, just one thing. So many of our systems are just one thing, and all of those things are falling apart. I hear that you've got oranges in Florida that don't turn orange. They've got the green-orange disease, is it, or whatever it's called. They stay green, they won't turn orange, and they use massive amounts of glyphosate in the inter-row to keep all the so-called weeds out. And when people stop doing that and put multi-species covers in the inter-row instead of using glyphosate to keep the inter-row clean, funnily enough, the oranges go orange. So, you know, so we've reduced biodiversity in so many of our systems, and then we've got these trace element deficiencies in plants, animals and people. And of course, so all of that is as well as the economic issues. I mean, if we're suffering from all of these problems that relate to soil, of course it is going to cost us more money. I mean, if we're talking about economics, look at the medical bill, if you like to call it that. Like, how much money is spent on human health in the United States? I think you spend more per capita than any country in the world on human health. And I think if you rank this population in terms of its wellness, I think you're about 17th on that list. So 16 other countries that have better health. The population is healthier than the American population, but you spend twice as much as any other country on, you know, dealing with the problem, like dealing with the symptoms. And the problem is basically this: soil degradation, environmental pollution, reduced biodiversity, trace element deficiency, etc. So we're told that we need to produce more to get out of this mess. That's what the message always is. And again, that's coming from the big agrochemical companies, you know, produce more, use more inputs, buy more of our stuff. It's not actually about maximising yield, it's about optimising profit. And there's been some really good studies that have come out in the United States recently. One of those was one that Jonathan Lundgren, who I mentioned about the insect apocalypse, he also had a great study showing that the maximum profit or optimum profit is well below maximum yield. So, you know, you don't need to apply all those inputs, and you need to, in a diverse system, in actual fact, diversity replaces almost every input that you can think of that we use in agriculture. And of course we have to regenerate the resource base. So that was really all I wanted to say about the economy, because I think that figure from Darrin Qualman really shows it all. The input providers are taking 98% of what everyone that's working really hard to produce is what you're producing. And I would like to see that the green line be right up there level with the blue line. We really want 98% of the value of agricultural production to go to the people who produce it, not 98% of it go to input providers. And that is going to require healthy soil. And I think intuitively you all know that. I don't think we have to be rocket scientists, as they say, to actually draw that link. So that was all I really wanted to say about the economics, and I thought maybe we could have more discussion in the groups about, well, how to, in practical terms, how to deal with that.
Thank you. And I just wanted to add just a minute about that